Now, in continuation of what we have discussed in the last class in qualitative analysis, I am going to continue this, covering, of course, most of the concepts. Now, as a sort of matching, this question is asked, that is evolution of gases, change of color of the material, like that. Now, first column, the property of the gas or the salt as the case may be, and column 2, the corresponding gas we have to match. Now, for example, let us consider a substance on heating becomes yellow in color, but on cooling it turns white. Probably you remember in the last class itself, at the beginning of our discussion, I have told you action of heat is an important reaction, and usually zinc salts will undergo this type of change. On heating, these salts turn yellow, but on cooling they become colorless, white. Now, column 2 you can notice corresponding to this 4. So, for A, here I mentioned the answer. For A, it is 4 zinc salts. Do you follow? Now, second, turns red litmus blue. Red litmus blue means the gas should be alkaline in nature. It should be alkaline in nature. Consider this. This is acidic. This is also acidic. This is amphoteric in nature, acidic. But 5 ammonia is basic in character. So, red litmus turning blue means this change takes place because of the presence of ammonia. Come to C, turns lead acetate paper black. A gas changing lead acetate paper black means it leads to the formation of lead sulfide, which is black in color. That means lead acetate is converted into lead sulfide. It is possible only if a sulfide is present in the salt. So, consider column 2. Various possibilities are there, but the only answer is 2, H2S. That is, hydrogen sulfide gas changes the color of lead acetate black because of the formation of lead sulfide. Please remember, it is not enough you know certain reactions, change of color for example, but you should be able to say that the color change leads to what product. That is very important. So, some reactions will give us an idea about the acidity or basicity, basic nature or acid nature. Then change of color is typical of several salts like zinc salts. Third one, gases reacting with several compounds giving different colored products. So, lead acetate paper changing black means it is due to the formation of lead sulfide, and lead sulfide formation is due to H2S. Come to D, turns acidified potassium dichromate solution green. Just like lead acetate changes to lead sulfide, here acidified potassium dichromate paper changes green. Acidified potassium dichromate solution changes green. Probably you know potassium dichromate is red orange. It changes green. It is acidified. Usually we use dilute sulfuric acid for acidifying potassium dichromate solution. So the corresponding chromium sulfate is formed, which is green. All right. Of these gases, which is capable of converting acidified potassium dichromate into green chromium sulfate? You omit 452 because only single answer matching type I have given. Now, sulfur dioxide. This is the property of sulfur dioxide gas. Sulfur dioxide turns acidified potassium dichromate solution green. All right. Next, it is very easy. Turns lime water milky. A gas which is capable of changing lime water milky. Immediately you will come to the conclusion that the gas is carbon dioxide. But I think in the last class I have mentioned, I think sulfur dioxide will also give this milkiness. So not only carbon dioxide but also sulfur dioxide is capable of giving this milkiness. So for E, CO2 and also sulfur dioxide. F, last one, fumes with ammonia. Now suppose I take a salt containing chloride radical like NaCl. You heat it with sulfuric acid. NaCl plus sulfuric acid will liberate HCl. And the characteristic test for hydrogen chloride gas is it fumes with ammonia gas. HCl plus NH3 forming ammonium chloride. So the gas fuming with ammonia should be acidic in nature. Please remember, ammonia is basic in nature. So any substance which is basic in nature is capable of reacting with another substance which is acidic in character. So HCl is the acidic gas which will fume with ammonia. Please also remember, suppose I give another reaction, G fumes with not ammonia but HCl. F is fuming with ammonia, answer is HCl. Just reverse it. The gas fuming with HCl is ammonia. Therefore, if I include that for this, the answer is ammonia 5. So, if two substances react, then for each reactant the same reaction I can consider. So, HCl fumes with ammonia to form ammonium chloride. Similarly, I can also say ammonia fumes with HCl giving the same product ammonium chloride. So, fuming with NH3 or fuming with HCl, in both the cases the same is the product. Do you follow? Okay.